Okay, so we talked about in class a little bit already that cars depreciate. They lose value. A home typically either keeps its value or gains it. Occasionally, in the case of the housing market crash back in 2008, it'll lose it. But it's pretty uncommon for homes to just like lose value guaranteed. Cars are guaranteed to lose value because we're using them every day, and guaranteed, even if you do frequent oil change and frequent maintenance, like something's gonna happen. Yeah, and it's gonna break down, it's gonna get worn down, and eventually it's gonna stop working. A house typically doesn't just stop working. It might get old, but usually a house is meant to last for a very long time. Cars are not meant to last as long, so they lose value. So what we're looking at today, again, is a very simplified version of losing value called a straight line. It's just like over time, you're losing the exact same amount of value every single year. It's just kind of a simpler way of looking at it. The next lesson is going to be a more accurate way of looking at how depreciation mathematically happens on a car's value. But we start off with kind of a simplified situation. So number one, suppose that you purchased a car for $27,000. According to your online research, because there is stuff online that shows you historically how cars have lost value, this make and model of car loses all of its marketable value after 12 years. Again, pretty oversimplified situation. Technically, if you even got like a piece of junk car that's not running at all, you can probably sell it for something, for parts or scrap metal even. So this is oversimplifying, saying it is worth $0 after 12 years. Oversimplified, but that's the purpose for this question. And again, that is, it depreciates to a value, it loses all its value to a value of $0 12 years after you buy it. So what we're going to do is we're going to create an equation that models this situation using the straight line depreciation. So pay attention to what it says, because again, we're going to have straight line depreciation. The next lesson will be exponential. So on your formula sheet, again, we're looking at this equation here, equation of a straight line, right? And when it says, what is just the slope? That's just the m, right? We wrote that in class. M is the slope. So that's going to be just this little piece right here. We do need to find the m to write the full equation. So I'm going to copy this over. This is the slope. Slope is, again, m, equals, again, that negative is there. Make sure you catch that, because, again, our value is dropping, so our slope needs to be negative. Negative on top, we have the starting value of the car over the number of years it takes to lose all value. I can't remember exactly how it says it here. I'm just paraphrasing. Number of years to depreciate. We can go ahead and say that. Depreciate. So this will be the slope of our line, and it's going to be the rate at which this car loses value. So go ahead and plug that in. What's the starting value of the car? Again, we have negative. What's the starting value of car? What's the number of years it takes to depreciate? Starting value is 27,000. Number of years to depreciate is 12. Yeah. Then you're going to go ahead and go to a calculator. We've got 27,000 over 12. Okay, so we have negative 2250. That's our slope. And again, if you remember way back when from Algebra 1, slope is the rate of change. So what that means is that's how much value you're losing on the car every single year. And again, this is oversimplified. Exponential models it a lot better. But that's just a simplification of how, again, we can think about cars losing value. Every single year, it would lose $22.50. Now, it says that this car depreciates in a straight line form. What is the straight line depreciation equation? What this means is they want us to write the equation of a straight line, which is y equals mx plus b. So remember, again, way back when from algebra or geometry even, we did this then. The y and the x stayed put. It's the m and the b that get switched out. Yeah. So we're going to replace our m, which we just found here, and we're going to replace our b, and the y and the x are going to stay put. And then that's our equation. We could graph it, and it would model how this car loses value over time. So I have y equals, our m is once again negative 2250, so I'm going to pop that in there. X stays put. Again, the y and the x stay put so that we could plug this into a graphing calculator and graph it or whatever, yeah? And let's go back to our equation here. Remember that it tells you also what b is. B is the starting value of the car. So plus, what is once again the starting value of this car? What am I going to plug in for b? 27,000. That's our y-intercept. And boom, that's it. If it says, what is the linear depreciation equation? Notice I make a little note here. When asked to write the equation, leave y and x. So it'll look something like that, right? And that's what we have. So again, this equation models for this particular car how it's going to lose value over time. And then we can use this equation to actually determine, or I should say estimate, how much value it would have after a certain number of years. So I want you to try this one more time on this one. You want to find what is the linear depreciation equation. That means this is our end goal. Notice they are not asking directly for the slope like they did here, but we do need to know m and we do need to know b to get the equation. So you still need to find m and then b and then pop them in. Go ahead and try it. Okay, so m is still negative starting value of the car over number of years to depreciate. I'm just going to go ahead and say number of years. So you should have gotten negative starting value is 35,000. Number of years is 10. This should be just chop off the 0, right? Negative 3,500. So there's our m. And then this is also, this 35,000, that will also be the b. Because again, b is just the starting value of the car. So here's my equation. I've got y equals mx plus b. The y and the x are going to stay put, and I'm just going to pop in my m and my b. So m is negative 3,500. My x gets dropped down. Plus my b is once again 35,000, the starting value of the car. Once more, that's all right here. Here's what m equals, here's what b equals, and then it tells you to leave the y and the x. So reference that formula sheet. That is our answer because it says, what is the equation? That's the equation. So again, this is going to model how this car is going to lose value. And again, in fact, it's going to lose $3,500 every year in value. Now, what we can do is we can use these equations to estimate and predict the future. I know a lot of us sometimes are like, what's the use of math? Am I really ever going to use this? Well, for a lot of this stuff, you might not ever use it, but a lot of the luxuries you have in life are because people do. People do use math to make predictions, to make models. All the computer stuff obviously is very heavy in math. So we're going to use this equation to predict the future. And again, there are people in real life who do that for us. We don't have to do it ourselves, but they do it for us. So what we're given here is immediately the equation. So they're telling us the equation for this particular car, and we are going to use it to figure out how much will this car be worth after 5 years. So we've done a question like this before. I can't remember what unit it was in, where we have to plug into the equation. Oh, I think it was the housing unit, actually. So what you have to do is read carefully and understand what your variables are. We have y, we have x. I'm going to write it here from the formula sheet, but y is the value of the vehicle, value of the car. X is going to be the number of years. You have to know this. If it doesn't tell you it in the question, it tells you it on the formula sheet. So what we need to realize here is we can plug into either y or x because this equation is so easy to work with. We can plug into either. So you need to focus on what you're given because that's what gets plugged in. How much will this car be worth after 5 years? So am I going to plug 5 into x or to y based on what x and y represent? I'm plugging that into x. X represents the number of years. So what's going to happen is that's going to go in for x. And I'm just going to do whatever I need to do to solve for the other variable, and hey, I'm done. So I got negative 4,000. X is 5 plus 32,000. Let's go ahead and take this to a calculator. You cannot drop that negative, otherwise you will get the wrong answer. Negative 4,000 times 5 plus 32,000. Okay, you should have gotten 12,000. Now again, ask yourself if your answer makes sense. How much will this car be worth? It'll be worth 12,000. Well, hey, that makes sense to start with. That's a dollar amount. As well as that, it's less than what it was to begin with. 32,000 is the starting value of the car. So if I end up with a bigger number than 32,000, you probably drop this negative. Cars, again, are going to lose value, not gain it. So let's go ahead and try it again. But same thing. You need to understand that y is the, not starting value. Y is going to be a value of the car. X is going to be number of years. We are given 12,000. Ask yourself if that's Y or if that's X. Plug it in and then do what you need to do. If you're a little confused here, this one is going to be a little different than the last one, so you can check it in a second if you're not sure. Okay, so Y is the value of the car. That's going to go in for Y. So here's why this problem is different. I'm going to pop 12,000 in where Y goes, and I'm going to have to move stuff over. Here, my variable was already by itself, and so we just popped that whole thing in the calculator. It was good to go. But here, my variable is not by itself, so we're going to have to move some stuff over. So what do we need to move first here? If you were kind of confused, if you weren't sure that's where Y went, or where we plugged into, what am I going to move first to get the X by itself? Well, you should be subtracting the 32,000. I can't touch the 4,000 yet. Be careful here. This is going to drop down. Haven't touched that yet. This is 12,000 minus 32,000. You are going to get a negative. If you drop the negative, you're going to end up with the wrong answer. And then what do we do from here to get the X by itself? We're going to divide that 4,000 away. Now, again, the reason why I can't drop my negative is because negative over a negative gives me a positive. If we go ahead and take that to the calculator, we're going to get 5, actually. 5 years is what it ends up being. If you drop one of these negatives accidentally, you might end up with -5 and might get a little confused. So, we've done this before, so I didn't really do that many practice problems with it. In your homework, you will either be asked to write the equation, and you'll kind of see how that works in the homework. It'll be like drop downs probably. Or you'll be asked to plug into the equation. Remember, you can plug into X or to Y. It's based on what you're given. We were given 5 years here, so we plugged into X. We were given $12,000, so we plugged into Y. Be careful. Check with me if you get those jumbled up. You're going to get these answers wrong.